Okay, so this is a video that supplements the class meetings from Monday, August 28th. So basically, I'm cleaning up the mess I made, and you have my apologies for that. First, I was supposed to cover section 1.3 and 1.4. I had misremembered from the schedule. So I will go through section 1.4 problems. But before I do that, I also want to revisit a problem that I did cover yesterday from section 1.3, problems number 17 and 18, which the way I did them were by far the most challenging. And there actually is a far easier way to work out these problems, and I'm going to show you that right now. Okay, so for this problem 17 here, the goal is to evaluate all 6 trigonometric functions at a given angle theta. And as we've seen in many problems, if you have x and y corresponding to that angle theta, then you can get r using the Pythagorean theorem. R is equal to the square root of x squared plus y squared. And then you can evaluate all 6 trig functions using the definition, like sine being y over r, cosine being x over r, etc. Now, for this problem, as I mentioned during class, you're not given this particular x and y like you are in other problems. You're given a relationship between them. This equation of a line 5x plus y equals 0, and you're also given that x is less than or equal to 0. So all you would need to do is choose an x value that satisfies the condition given here. So I would not recommend choosing x equal to 0, because that can cause some problems due to dividing by 0 later. So I would recommend choosing a non-zero value of x that satisfies this condition. So for example, x equal to -1. So you go ahead and substitute x equal -1 into the equation of a line. 5x plus y equals 0, of course, is equivalent to y equals minus 5x just by rearranging. So you go ahead and substitute x equal -1, and you end up with y equal to plus 5. So now you have the x and y that you need. So then you go ahead and get your r value using a Pythagorean theorem. So r is equal to the square root of x squared plus y squared. So in this case, it turns out to be the square root of 26. And now you just go ahead and do sine t is y over r. And you get your answer in unrationalized form. And then you go ahead and rationalize the denominator. And then you're off to the races. Since you have x, y, and r, you can just apply the definitions of the 6 trig functions. So cosine t would be x over r. You have r from before. X is chosen to be -1. So then you have this, and then you go ahead and again rationalize the denominator. And after that, as I mentioned in class, you can use these relationships also. Once you have sine and cosine, you can use those values to get tangent, cotangent, secant, cosecant. So in this problem, number 17, and also number 18, it's the same type of problem, but also having these graphs where you need to choose the correct line. So again, you need an x and y value. You choose an x value, you substitute that chosen x value in here. Again, I suggest just choosing -1, and then you get a this y value. And then you can use sine t is y over r, cosine t is x over r, etc. to get the values of all 6 trig functions. Okay, so sorry about presenting a harder approach last time. Instinctively I tried to avoid solving problems by simply making an arbitrary choice, unless there's no other option. Okay, now for the section that was not covered yesterday, I thought about simply waiting till Wednesday's class, but I have 2 sections to cover on Wednesday also. So unfortunately, there's no ideal solution to this dilemma, so that's why I'm making this video. And then I'll try to make time on Wednesday during class for any questions that anyone might have about this section. So 1.4 continues working with excuse me, evaluation of trigonometric functions and dealing with quadrants, etc. So for this first problem, you're given that sine of a certain angle theta is positive, and tangent is also positive. So which quadrant would that angle be in? Now remember from class, the quadrants 1, 2, 3, and 4 are determined by whether x is positive and negative, or y is positive and negative. So we need to get a handle on whether x and y are positive or negative based on what we're given here. Now, you use a definition of these functions. So sine of theta is y over r. R is always positive. So if sine is positive, that means that y and r have to have the same sign. So that means that y is positive. So right off the bat, you know you're in quadrants 1 or 2. And then for tangent is defined to be y over x. Since that is given to be positive, and you know from the previous step that y is positive, x and y must be the same sign. So x is also positive. So both x and y are positive. That tells you that you are in quadrant 1. So using the definitions of whatever trig functions are given, whether they're positive or negative, determine if x and y are positive or negative. And that tells you what quadrant you're in. Okay. You have to determine whether a statement is possible or impossible. And this is based on what values the 6 trigonometric functions are allowed to assume. You recall from lower level math courses, a function such as these trigonometric functions has a domain and a range. The domain consists of possible input values. The range consists of possible output values. So these 6 trigonometric functions have different ranges. So here are the ranges of all 6 described right here. Sine and cosine can only assume values between -1 and 1, including those endpoints -1 and 1. So that tells you right off the bat that this statement is at least possible. Now, 2 of these choices indicate that's possible. You have to select a correct reason. And it's this first one because -1 to 1 is a range of cosine, not 0 to infinity. Tangent and cotangent are able to assume any real value. So -infinity to infinity is the range. Now, cosine has to be between -1 and 1. So if you get secant by taking 1 over cosine, that's from a definition, you find that secant has to be greater than or equal to 1 or less than or equal to -1. So the part that's strictly between -1 and 1 is cut out. And the same is true of cosecant. So because sine t and cosine t must lie inside this interval, secant and cosecant must lie outside of it, although all 4 functions are allowed to be equal to -1 or 1. So this is one way of writing the ranges of these functions using inequalities. But here in the problem, the ranges are specified using intervals, and that's what I've done for you right here. So, and we may not have seen this before, but the way we specify intervals, we use square brackets to indicate that an endpoint value is included. We use parentheses to indicate that an endpoint value is not included. So because sine and cosine, the range is all values less than or equal to 1 and greater than or equal to -1, we use square brackets. So it indicates that -1 and 1 are included in the range. With infinity or minus infinity, you always use a parenthesis because infinity is not a specific number. So such as 1 or -1. So tangent and cotangent, because they're allowed to assume all real values, we write the domain as -infinity, infinity in parentheses. And then secant and cosecant, the range cannot be expressed using a single interval. You have two separated intervals. So it's all values greater than or equal to 1. So we have 1 to infinity, and we have a square bracket to the left of a 1 because 1 is included in the range. Oh, sorry, I have a typo here. That should be minus infinity to minus 1. So all values less than or equal to minus 1 are included in the range of secant and cosecant also. It's the way we write that. We have a parenthesis for minus infinity, but we have a square bracket after the minus 1, a closing square bracket, because minus 1 is part of the range. Okay. So sets such as domains and ranges, it can be expressed using either inequalities or intervals. So this problem uses intervals, but it's good to be familiar with either way of expressing these domains. So this okay. So this specification is an interval square bracket minus 1 to 1 is equivalent to this. And then here we have minus infinity to infinity is expressed using inequalities here, and then these two intervals can be expressed as two separate inequalities. Yeah. This is the same kind of statement. Is this statement tangent theta equal minus 5.5? Is it possible or impossible? Well, it was mentioned in the previous problem. Tangent can assume any real number as a value. So this statement is possible, but we have to select the correct reason. Statements B and D indicate that it is possible. This would indicate that tangent can only be negative, but that's not true. Tangent can be positive or negative. So choice B is the correct range in that case. We're going to see a lot of trigonometric identities throughout the semester. This seems to be the main one, perhaps the only one that students remember, that sine of an angle squared plus cosine of an angle squared is equal to 1. So this is actually true as a consequence of a Pythagorean theorem. So indicate that it is possible, so it's choice A or C. But this statement, sine plus cosine equal to 1 without the squaring, that is not true. So it has to be choice C. I want to mention this is these expressions, sine squared theta and cosine squared theta, are written in an unusual way because I mentioned earlier that sine by itself doesn't really mean anything. You have to take sine of an angle, and similarly cosine of an angle. So this statement here, sine squared theta plus cosine squared theta is equal to 1, is equivalent to, I take sine, I'll use t in place of theta as I mentioned before, sine t squared plus cosine t squared is equal to 1. So you evaluate sine at your angle theta or t, and then that number is what gets squared. It's similar for cosine of theta, but it's conventionally written this way. I guess just because it looks a little cleaner and it doesn't clutter things up with parentheses. Okay. But I want to make clear this is what you're squaring: sine theta or cosine theta. So reciprocal identities are relationships between trigonometric functions that involve reciprocals. We've seen these relationships before. Secant of t is equal to 1 over cosine t is one of the reciprocal identities. So here you're given a cosine theta is equal to 3/5. So what is secant of that angle? You just use this identity. All you're doing is taking reciprocal of the cosine, and then you get 5/3. This problem, another reciprocal identity, cosecant is 1 over sine. You're given the sine of an angle, so to get cosecant of that same angle, you're just going to flip a fraction again. And then one more reciprocal identity. Cotangent is 1 over tangent, so if you're given a tangent, you just take reciprocal of that. That gives you the cotangent of that angle. That's useful again in this problem. Tangent theta is given to be 0.365, but as used here, cotangent is 1 over tangent. So you're just going to take 1 over this value. In this case, you'd have to use your calculator, and after taking a reciprocal and rounding to 3 decimal places, then this is the value that you get. Okay, here again, we're using a reciprocal identity. The work involved in this problem deals with rationalizing the denominator. So you're given a cosecant of an angle. So earlier we used the fact that cosecant is 1 over sine. Well, reciprocal identities go the other way too, that you have sine is 1 over cosecant. So your unrationalized answer is 6 over the square root of 52. But then the goal is to rationalize that and also make sure that the fraction is in lowest terms, that you have any square roots that can be simplified. You want to do that too. So if I just go ahead and only deal for rationalization, I'm going to take this fraction. Sorry, it's a pain trying to select text to highlight it. So 6 over square root of 52. If I multiply the numerator and denominator by square root of 52, then I get 6 square root of 52 over 52. But this is not in simplest form, because 52 is equal to 4 times 13. So square root of 52, if I break 52 down into 4 and 13, well, square root of 4 simplifies to 2. So now what I have is 12 times square root of 52 over 52. And a 12 over 52 can be put in lowest terms. If you divide the numerator and denominator by 4, then you get this answer, 3 root 13 over 13. So be sure to, whatever number you're taking a square root of, be sure to factor it in case there's any simplification that can be made. Actually, I'm going to go ahead and write that in this case. So 6 square root of 52, 2 turns out to be, so square root of 52 has been expressed as 2 square root of 13. And right here, this 12 and this 52, you divide both of them by 4. You end up with that. Okay, here we have a statement, tangent 90 degrees equal to 1 over cotangent of 90 degrees. Now, normally you might think, oh, that's a valid statement because we have this reciprocal identity. Tangent of an angle is 1 over cotangent of that angle. The problem is, this doesn't apply if you're performing a division by 0. Cotangent of 90 degrees is equal to 0. So cotangent is 0 at these angles, 90, 270, 450. So you start out with 90, and then you keep adding 180 to it, and cotangent is equal to 0 at all of those angles. Tangent is equal to 0 at all multiples of 180. So 0, 180, 360, 540, and so on. So because cotangent is equal to 0, that tells us that tangent is undefined at 90 degrees. So if you consider where cotangent is equal to 0, these angles, tangent is undefined at those angles. Similarly, tangent is equal to 0 at these angles, 0, 180, 360. So cotangent is undefined at those same angles. So it's important to be aware of at which angles cotangent or tangent are equal to 0, and therefore the upper function is undefined there. Okay. So this is the correct reason as to why it's wrong. That you have 0, and then you end up dividing by 0, so you can't evaluate tangent at 90 degrees. B is wrong because cotangent at 90 degrees certainly is defined. It's 0. Statement C is wrong because in general this reciprocal identity does hold. The only time it doesn't hold is for the angles at which cotangent is equal to 0. Okay, here we're given an angle, 12 degrees, and the goal is to determine whether the 6 trigonometric functions are positive or negative. This angle, 12 degrees, is in quadrant 1. So any angle that's between 0 and 90, exclusive of 0 and 90, is in quadrant 1. So x and y are positive, therefore sine and cosine are positive, and therefore everything else is going to be positive. You can use these relationships once you know whether sine and cosine are positive or negative. Because of these relationships between all the other trigonometric functions and sine and cosine, you can determine their sign from there. Okay. Here is, in a sense, kind of the opposite problem. You're given that sine of an angle is positive and cosine of that same angle is negative. Which quadrant are you in? So sine of an angle is equal to y over r, and r is always positive. So if sine is positive, then y must be positive. Similarly, cosine is given to be negative, therefore x must be negative. Well, which quadrant has y positive and x negative? That would be quadrant 2. So remember, sine corresponds to a y value, cosine corresponds to an x value. Same kind of problem. You're given a tangent and cotangent of an angle are negative. Now, tangent is defined to be y over x. So if that is negative, that can only happen if x and y have opposite signs. That only narrows you down to 2 quadrants. It could be quadrant 2 or quadrant 4. There's not enough information here to determine which of those 2 it is, but it is one of the choices, and that actually is a correct choice. Similarly, if it was positive, that would be quadrant 1 or quadrant 3, because then the x and y are either both positive or both negative. In this case, you can narrow down to a specific quadrant. So because cosine is negative, that tells you that x is negative. Because cosecant is negative, cosecant is equal to r over y. R is always positive, so if a whole fraction is negative, that means that y must be negative. In other words, both x and y are negative. That has to be quadrant 3. All right, here, same kind of problem. You're given that sine is positive, tangent is negative. If sine is positive, y must be positive. Tangent is y over x. Y is known to be positive. If a whole fraction is negative, the only way that can happen is if y and x have opposite signs. So x must be negative. So if y is positive but x is negative, that must be quadrant 2. Okay. Here you're given the value of a specific trig function, in this case sine, at a certain angle, and you're given that the angle is in quadrant 1. And the goal is to find a value of the remaining 5 trigonometric functions at this angle. So the fact that t or theta is in quadrant 1, x and y are both positive, so therefore cosine has to be positive. Now you have this identity, cosine squared t plus sine squared t is equal to 1. Now you can rearrange this identity to solve for cosine, and this is a very, very important identity to know. Cosine of t is equal to square root of 1 minus sine squared t. Now, the problem with this equation here is you don't necessarily know if you're supposed to choose a positive or negative square root. In this case, we do know that because we're told we're in quadrant 1, so x is positive, therefore cosine is positive. In this case, therefore, we choose a positive square root. Here I've just worked through the algebra, so if I take square root of 5 over 7 and square that, so I'll have 5 up top and then 49 down below. So then I get, so I have square root of 44 over 49, and then I simplify that as much as I can. So I get 2 square root of 11 over 7. And I leave it at that because I've seen from earlier that cosine has to be positive. It's a lot less work after this point because now that you have the sine of the angle theta and cosine of that angle theta, you can use these relationships to work out the rest of the trig functions. So in this case, we have cosecant of theta. Cosecant is 1 over sine. So you would flip this fraction, but then don't forget to rationalize the denominator. So you start with 7 over square root of 5. But then you rationalize and you get 7 times square root of 5 over 5. And then you would keep going from there to fill in the remaining blanks. Okay, this is the same kind of problem. You're given that the value of sine at a certain angle. Here you're not told a quadrant, but you are told that cosine is negative. So in this case, you're going to use the same tactic as before. You can use this identity and rearrange it to solve for cosine of theta. So if we go back to that, this is what you're going to use. Cosine t is equal to square root of 1 minus sine squared t. You just have to remember, because of the information that you're given, cosine being negative, after you work out square root, you must choose the negative square root. And then once you have sine and cosine of theta, you can use the relationships of the other trig functions with sine and cosine to figure out those values, and be sure to rationalize any denominators as needed. Okay. Yeah, this is the same kind of problem. You're given that the angle theta is in quadrant 2. That tells you that y is positive, x is negative. Cotangent is given to be x over y. Now, because we only know the ratio of x to y, any x and y value that satisfy that ratio will work. So for example, we could take x to be minus the square root of 3 and y equal 8. The minus has to be associated with the x because we're in quadrant 2. So the y value has to be positive, the x value has to be negative. So now that we have an x value and a y value, we can get an r value using the Pythagorean theorem. So now that we have x, y, and r, we can obtain the values of all of the other 5 remaining trigonometric functions. So sine t is y over r, cosine t is x over r, and so on. And again, be sure to rationalize denominators as needed. Okay, here we're only dealing with one trigonometric function, tangent theta, given that sine theta is equal to -1/4. You're also given that the angle theta is in quadrant 4. Quadrant 4, x is positive, y is negative. And sure enough, the sine is negative. Because x is positive, that tells us that cosine is positive. So as in previous problems, we're using this relationship. Cosine is equal to square root of 1 minus sine squared. But because we're in quadrant 4, cosine is positive. Be sure to take the positive square root. Okay. Once you have cosine, we really want tangent, but tangent is equal to sine over cosine. You just take the given value for sine, the computed value for cosine, and take sine over cosine, rationalize the denominator if it's necessary in this case, and that gives you the value of tangent. Similar problem, we're given that sine theta is equal to 1. So when sine theta is equal to 1, doesn't matter which square root you take because you apply this identity again. Cosine of t is equal to square root of 1 minus sine t squared, and you're just going to get 0. So cosine is 0. So now you know sine and cosine, so you can work out the values of the other 4 trig functions using the sine and cosine values, but some of these will be undefined. So tangent, for instance, is sine over cosine. That's 1 over 0. So you would select that choice B here for tangent, that the function is undefined. Secant will also be undefined. I've come to the end. Okay, so I'll try to make time during class on Wednesday for any questions about this material, or you can shoot me an email or a Canvas message if you have any difficulty. So because section 1.4 was covered a little bit later, I've pushed back the due date for that assignment a little bit, and for a couple of our assignments too. So thank you for watching, and apologize for messing up yesterday.